Lesson 1-2, Inductive Reasoning. It's an activity, and we'll actually do this in class. How many different ways can two people shake hands? This one's pretty obvious, and I don't mean different techniques. I mean, they're going to shake hands like normal people. There's only one way they can do that. How about if I have three people? Well, he can shake hands with him. That's one way. He can shake hands with her or him. That's two ways. So that's one, that's two. Then these two people can shake hands. That's three. He's shaking hands with him and him. But that also counts for this one. So that's the same one. And that's the same one as this. That's the same one as this. That's three. How about four people? So that's four choices. I'm going to let you figure that out in class, or you can do it now. Pause the tape, and it shouldn't take that long. But I'll leave it up to you. Can we find a pattern? So we had 1, 3. And can we describe it algebraically? I'm going to say no. We could do it, and if you want to try it, go for it. It's pretty tricky stuff, but you can put it on a table. You could say that this is the first one, this is the second one, the third one, the fourth one. You can say that it goes 1, 1. 1, 2 becomes 1, 3, 3, 4. I don't know. So you got a lot to play with there if you want, but let's just leave it at no for now. It's outside the scope of this class. We're looking for patterns. So you're going to guess based on what you see in the first couple patterns. And I will give you, no, I'm not even going to give you a hint. We'll try it in class. So this is an example of what we do in geometry. We look for a pattern. We've done that. Make a conjecture. And this is where I get the, what? A guess. But more than that. An educated guess. And this leads to a proof. We say, I think this is what's going on, and then we prove it. And that's here. And that is one of the things people enjoy the least about geometry class is proving things. So I'm going to give you some very simple proofs to do over the next few months. You do not need to worry about it. I'll keep your life as simple as possible. But let's play this game. What happens when we add any two numbers? Odd numbers. Just give me some odds. 3 and 5, 7 and 11, -1 and 5. I always get 4, 18, 8. And it would appear to me I always get an even number. Have I proven it? Nope. This is inductive. I've kind of induced it. We did this with the fruit for thought, and we'll do it again. You say, well, I think this makes sense. Let me try this. And then you keep trying, and it looks like all the pieces fit. And you say, as best I can tell, this is the answer. We make mistakes. Generally speaking, this works for us. We know a certain child in the family is going to borrow the car. We can always bet that it's going to come back with no gas. Things like that. Try another one. First, n odd positive integers. So 1 plus 3, 1 plus 3 plus 5, 1 plus 3 plus 5 plus 7. I actually think the challenging part here is that saying, what are they talking about here? That takes a little while. Well, sum, that means add them up. N odd positive. First n odd positive integers. What that n means is the first one of them, 3 of them, pardon me, 2 of them, 3 of them, 4 of them. So this is the first 2. This is the first 3, first 4, so on and so on. And do we see a pattern? 1 plus 3 is 4. 1 plus 3 plus 5 is 9. 1 plus 3 plus 5 plus 7 is 16. So there's our numbers, 4, 9, 16. What's going to be next? I am sure you can figure that out. And it's interesting. Why does that happen? Well, we're not going there. We're just saying, what's conjecture? So I will say it's always n squared. And hopefully you understand what I mean. I don't want to spoon feed you too much, so I'll let you have some fun too. Now, what's the product of any two odd numbers? 1 times 3, 11 times 17. I'm going to do 11 so I can show you a trick, times 23. This is 3. Now 11 times 17 is 187. To multiply by 11 in your head, add the two digits. So 1 plus 7 is 8. Put it in the middle. So 11 times 23, 2, 3. Add the two digits. 2 plus 3 is 5. So what do we notice about these? 3, 187, 253. Looks like they're always going to be odd. Is there anything more life-shattering about them? No, that seems to be about it. Wish there was more than that. What's the product of the numbers n minus 1, n plus 1? So let's go with n equals 3. So it's 3 minus 1 times 3 plus 1. And that's 2 times 4 equals 8. How about if n was 5? 5 minus 1, 5 plus 1, 4 times 6, 24. N equals 10. 10 minus 1, 10 plus 1, 9 times 11 equals 99. I've noticed something here. 3 squared equals 9. 5 squared equals 25. 10 squared equals 100. So it would appear to be n squared minus 1. We can actually prove that if we wanted. Because n minus 1 times n plus 1 is n squared minus 1. That's some heavy-duty algebra. Don't get hung up on that. Just look for the pattern. And if you're not even sure, just say, I'm not sure. I'm not sure what that pattern is describing. And don't worry about it. That's how we prove things inductively. It's not a really good proof, but it works for us in the real world. Now the question is, how do we disprove something? And I'm not even sure if that's a word, but it didn't pop up on my computer as a bad spelling, so I'm going to assume it is. And the best way to do that is find a counterexample. And the teacher will say, hey, if you study hard in my class, you'll get an A. And you study really hard, you really do, you put the time of day and you get a B. Like, well, you lied to me. That's not a true conjecture. So you look for a counterexample. So the sum of two numbers is always greater than the larger of the two numbers. Sum of two numbers is always greater than the larger of two numbers. So pick two numbers, 4 and 5. 4 plus 5 is 9. Works. Negative 3 plus 2. Sum of two numbers, always greater than the larger of the two numbers, equals negative 1. Well, it didn't work. So that's a counterexample. 0 plus 5 equals 5. It's not greater than that number. It's got to be greater than. Doesn't work. So the conjecture is not true. Here's another one. All shapes with four sides have the same length are all shapes with four sides that are the same length are squares. So we're saying this, and these little tick marks means the same length. Is that a square? Sure looks like one. Can we come up with a counterexample? What if they were bent a little more and the sides were all the same length? Not a square. And since we're all lazy human beings, busy people and things to do, just write false. What we're saying there is the conjecture is false. That's it. We'll try some problems in class. Hope that made sense. Good luck.